Hello guys, in this video I'm going to explain the temperature sensors. The content that I'm going to cover in this video is their types of temperature sensors and their working principles. And without further ado, let's get started. Now let us see where these temperatures are used in. Their temperature sensors are used in the power plants, and they are also used in the electric ovens, and they are also used in the refrigerator freezers. They are also used in a computer and many other devices that requires the temperature monitoring. Now let us discuss about what is meant by temperature sensors. The temperature sensor is a device that detects and measures the hotness and coldness and is converted into electrical signal. That means we can clearly say that these temperature sensors can measure the hotness and coldness of the body, and this measured quantity can be converted into the electrical signal. Example like thermocouple. In thermocouple, through thermocouple we used to measure our temperature. Later on, I'm going to explain in the thermocouple in the next slide. Now let us directly move into their uses. The temperature sensors basically they are used in the industries. Why these temperatures are used in the industries? Because in industries, there are different kind of industries that rely on the temperature in certain range, like processing of food, manufacture of paper, goods, storage, pharmaceutical, etc. For that, there are various types of sensing devices that are used to detect the temperature in the industry. So to detect the temperature in industry, so the temperature detecting device thermometer play a key role in the industry, flexible and reliable and economical. Now, to measure the value of temperature, some of the following phenomena is needed. Change in the physical dimension or characteristic of liquid, metal and gas, change in electrical resistance, thermal effect, and the radiant energy. Now let us discuss the type of temperature sensors. One of the type of temperature sensor is a biometric thermometer. A thermometer which uses two different metal strips for converting the displacement of temperature into mechanical. The metal used in the thermometer are steels, copper, and brass. The steels are connected and they will enlarge at different rate once they heat it. The word biometric means that involves the two metals that are going to measure the temperature. Biometric thermometer uses two fundamental principles. One of the principles says that all matter expand or contract with change in temperature. That means whenever there is a change in temperature, the matter will contract or expand in response to the change in temperature. The second principle says that temperature coefficient of the expansion rate is not same for all the matter. Therefore, rate of expansion or contraction is different. We know that whenever there is change in temperature, the different matter will have different rate of expansion and contraction rate. Therefore, the temperature coefficient of the different matter will not same for each other. A biometric thermometer is made up of two metals. Whenever there is change in temperature, these metals are either going to expand or contract. Due to the difference in the rate of expansion or the contraction of this matter, the biometric thermometer is going to change its shape. The change in the deflection is proportional to the change in the thermometer. Now, as you can see in this diagram that involves the two metals, the blue one is in the metal A and red is the metal B. When these metals they connected each other, they will form a biometric thermometer. Now here you can see in this diagram that there is a revolt. Revolt is a method in which these two metal strips are connected to each other. Now we know that every metals will have a different rate of expansion and contraction rate. So therefore, these two metals will also have the different rate of expansion and contraction rate. So when these biometric strips are subjected to any change in temperature, because we know that these two metals has a different rate of expansion and contraction and different thermal expansion coefficient. So both these metals contracts and expand at different rate. Due to this difference in the thermal expansion rate, there will be bending of biometric string. So this result in bending of biometric strips with a change in temperature. So this is how in industry they measure the temperature from the biometric strips. Here you can see in the diagram that these two metals are connected with each other whenever there is change in the temperature. Since this metal, since there is a, since these two metals have a different rate of expansion and contraction, when these metals are subject to any change in temperature, then these two metals will either going to contract or expansion depending upon their expansion and contraction rates. Therefore, by looking at the contraction and the expansion of these two metals, then we can able to know the temperature, how much temperature is required for this expansion and contraction rate. So by looking at the contraction and expansion of the biometric strips, we can able to measure the temperature. This is how in industry it is measured the temperature. Now let us discuss what is meant by thermocouples. Now what is meant by thermocouple? Thermocouple is a temperature sensor or the transistor which is used to measure the variation of the temperature. Through thermocouple we can able to measure the temperatures. And thermocouple it can withstand at high temperatures, and thermocouple they are more durable, and thermocouple they are less expensive than any other device which is used to measure the temperatures. Thermocouple works on a three principles. The three principles of the thermocouples are Seebeck effect, Peter effect, and the Thomson effect. Each of the principles explain how the EMF is generated within the circuit. Now let us see the Seebeck effect. The Seebeck effect states that when two different or unlike metals are joined together at two junctions, electromotive force, also known as EMF, is generated at the two junctions. That means, as you can see in the diagram, that two dissimilar metals are joined together. When they join together, they form a two junction. The one of the junction is hot junction, and one of the junction is cold junction. The hot junction and cold junction, they are the part of junction which form due to the welding of the two dissimilar metals. And hot junction means it's a major junction in which the temperature is measured, and cold junction is a reference junction through which the hot junction can able to measure the temperature. And these two dissimilar metals, they join together, they will form the hot and cold junction, and through this the EMF is generated at the two junction. Now the amount of EMF generated is different for the combination of the metals. Let us see the Peter effect. Before we move into the Peter effect, there is one of the drawback of the Seebeck effect. The Seebeck effect only states that when these two dissimilar metals they join together, they will form a junction. Because of the formation of the two junction, the EMF is created at the two junction. But it does not explain how this EMF is generated at the two junction. But in the Peter effect, it explains clearly that how this EMF is generated at the two junction. Now Peter effect states that when two dissimilar metals are joined together to form a two junction, EMF is generated within the circuit due to the difference temperature at the two junction of the metal. That means because of the difference in the temperature of these two junctions, the EMF is created. This is how the Peter effect explains the generation of the EMF at the two junction. Now let us see the Thomson effect. When the two unlike metals are joined to form a two junction, the potential exists within the circuit due to the temperature gradient along the entire length of the conductor within the circuit. Now the Thomson effect, what it says was Thomson effect also explains the generation of the EMF within the circuit, and the EMF generated at the circuit is due to the difference in the temperature of the two junction metal which is along the entire length of the conductor. Now let us discuss the construction of thermocouple. The construction of the thermocouple is so easy. Now thermocouple consists of two dissimilar metals welded together to form a two junction point. Here you can see in the diagram when two dissimilar metal. When they combine with each other, they form a two junction. One of the junction is hot junction, is exposed to the environment. Is a hot junction. Hot junction is a measure junction, is the measurement junction through which we can measure the temperature. The another junction is a cool junction, which is also known as reference junction. Now, whenever we change the temperature or increase the temperature at the hot junction, the EMF is produced within the circuit. Here you can see in the diagram there is a multivolt which is used to measure the voltage within the circuit. So whenever there is generation of EMF or the voltage across the circuit, so this voltmeter will measure the reading of the voltage within the circuit. That is how the thermocouples measure the voltage in terms of temperature. Now we know about the transistor. The transistor which converts the non-electrical quantity to electrical quantity. Since the temperature is a non-electrical quantity, through thermocouple we can convert the temperature into the voltage, and this is how the thermocouples help in measuring the EMF or voltage within the circuit. Now there are many different types of thermocouples, each with their own unique characteristic in terms of temperature, durability, vibration resistance, chemical resistance, and amplification compatibility. Now the type J, K, and T and E are the base metal thermocouple, and they are mostly used thermocouple, whereas type R, S, and B are the noble metal thermocouple, where they are often used in extreme high temperature application. Now let us discuss the types of thermocouple. There are several types of thermocouple. The chromic constant, the type E, which is a base metal thermocouple. Iron constant, the type J, is a base metal thermocouple, and chromic aluminum type K is also base metal thermocouple, and nickel type N is a noble metal thermocouple, and copper constant type T is a base metal thermocouple. Now let us look into their temperature range, sensitivity, inaccuracy, and their percentage. The common constant, the sensitivity is 80 microvolt per degree, with an inaccuracy of plus or minus 0.5% and measuring range of minus 200 degrees Celsius up to 900 degrees Celsius. The iron constant sensitivity is 60 microvolt per degree. Range is between minus 150 degrees Celsius to 1000 degrees Celsius. The copper constant sensitivity is 60 microvolt per degree, sub-zero minus 200 degree, and inaccuracy of plus or minus 0.75% up to 350 degrees Celsius. The common aluminum, the sensitivity is 45 microvolt per degree, and the range of temperature is between 700 degrees Celsius to 1200 degrees Celsius, and inaccuracy of plus or minus 0.75 degrees Celsius. The nickel, the sensitivity of 40 microvolt per degree and uncertainty of plus or minus 0.75%.